Good day, everyone. I'm Dr. Shakil Ahmed, and I'll be presenting our research paper, Enhancing Academic Support with AI, a case study of chatbot integration using Microsoft Copilot Studios at Jazan University. I'll begin by briefly explaining the motivation behind this work, followed by the system design and key findings from our pilot studies. Here is a list of my team. You can find out like this research is collaborative efforts. I am the principal author and I work closely with my co-authors from Jazan University and partner institutions. In this presentation, I'll first outline the background and motivation of this study. Then I'll briefly review related work, followed by our methodology and system design. I'll then present the key results and discussions, and finally conclude with the future research directions. So in background and motivation, in recent years, universities have been undergoing rapid digital transformation driven by the need to improve students' service and definitely operational efficiencies. One key challenge is the growing demand for real-time academic and administrative supports. So students expect immediate responses while traditional help desks are often slow and require significant human resources. So this is where AI chatbot play an important role. So they allow universities to provide continuous access, faster responses, and better engagement without increasing staff workload. On the right side, you can have a look. We can see that Saudi universities are already experiencing and experimenting with different chatbot platforms, including Microsoft Teams bots, IBM Watson, WhatsApp bots, custom AI solutions, and Microsoft Copilot Studio. So this shows a clear institutional interest in AI-driven sports systems. Our motivation was to explore how an easy to deploy no-code platform like Microsoft Copilot Studios so that can be used effectively in a real university environment to improve accessibility and definitely response speed, student engagement, and overall administrative efficiency was on the priority. So what was the basically the problem statement that is basically traditional academic support system at the universities, including Jazan University, still relies heavily on a human assistant. So as a result, students often experience long response times, especially for repetitive queries related to admissions, courses, schedules, and general information that could be available on the university website and Blackboard LMS system. So this also increases the administrative workload overload definitely on the staff side. To address this issue, the scope of our study focuses on the design, implementation, and evaluation of an AI-powered academic support chatbot that is basically developed using Microsoft Copilot Studio. So the chatbot was integrated directly into the university website and Blackboard LMS to provide a real-time access for students and faculty. So the relevance of this study lies in demonstrating how a no-code AI solutions can effectively reduce response time, improve user satisfaction, and support digital transformation initiatives in higher education institutions. Definitely on the basis of priority within the Saudi Arabian context as well. So based on this, our main research question asks how effective an AI chat was developed using Microsoft Copilot Studios. Definitely that can improve response time, user satisfaction, and overall academic support services at Jazan University. So what was the research objectives? Pretty clear, the reason behind because we are dealing with the AI chatbot. So the main objectives of this study were practical and implementation focused. First, we aim to automate frequently asked academic and administrative questions across two main platforms, the university websites and the Blackboard learning management systems. Secondly, we focused on reducing response time for both students and faculty by providing instant, AI-driven support instead of relying only on human assistance. Another important objective was to lower the administrative workload by definitely handling the repetitive queries automatically. So that's gonna allow your staff to focus on more complex tasks. Finally, our goal was to improve the overall student experience by using AI-driven support system that is accessible, responsive, and available all the time, not on some specific timing. So now the time to discuss about the theoretical framework, why that is really important, because to strengthen the conceptual foundation of our study, we grounded the chatbot design in three well-established learning theories. First, constructivism, this is basically the learning theory, emphasis that learning happens through active and on-demand interactions. In our context, the chatbot enables students to ask curious questions at the moment of need, supporting self-directed and contextual learning. Second, interaction equivalency theory suggests that effective learning can occur when one form of interaction is strong. Here, the chatbot enhances the learner content interactions by providing immediate, structured, and a very fast response without requiring a human mediation. So finally, students' engagement theory explains the link between engagement, satisfaction, and retention. By offering fast and accessible support, the chatbot increases engagement, so which in turn improves user satisfaction and continued use of academic services. So together, these theories explains why an AI-powered chatbot is not just a technical tool, but definitely pedagogically meaningful solutions for academic sports in higher education. Now, time to discuss about the system architecture. This slide shows the overall system architecture of the proposed chatbot. Because the system is built using Microsoft Copilot Studio, which is no-code platform designed for rapid chatbot development. So the chatbot uses NLP-based intent recognitions to understand user query and follows topic-based conversational flows. So Power Automatic is used to handle backend logic, workflow, and integration when definitely automation is required. The chatbot connects to a knowledge base and AI generated sources to provide accurate responses. So once published, the definitely the chatbot is deployed across multiple channels, including the university website and the Blackboard LMS system. They're gonna allow users to interact in real time from familiar platform. So this architectures basically enables fast deployment, scalability, and easy maintenance without the need for complex type of programming. The chatbot was trained using anonymized student queries, official university frequent asked questions, and documented academic procedures. So these inputs were processed through intent mapping and reprocessing, and then trained within Microsoft Copilot Studio using NLP-based topic modeling. So this the system was improved definitely using user feedback and confidence threshold tunings. It's gonna follow a semi-supervised learning approach as well. So this allowed the chatbot to gradually improve accuracy while maintaining privacy and data protection. In methodology, we adopted a formative research methodology to design, implement, and evaluate the AI-powered chatbot. The chatbot was developed using Microsoft Copilot Studio and deployed on the university website and Blackboard LMS system. A pilot study was conducted with 90 users, including students and faculty members. So the system workflow starts with the chatbot configuration, followed by NLP-based intent recognition, automation through Power Automate, and interaction across multiple channels. So performance was evaluated using key metrics that is such as like response time, user satisfaction, accuracy, and error handling. This slides definitely highlights the key performance results of the chatbot. The chatbot responded to queries in about 2 to 3 seconds, while traditional human support required 30 to 50 seconds on average. So this performance and definitely represents an improvement of nearly 20 times faster for general academic queries. The difference was statistically significant with p less than zero point zero 0.01. That is confirming the reliability of these results. In addition to performance, we evaluated user satisfaction. Around 68% of users reported being either satisfied or very satisfied with the chatbot. The overall satisfaction score was a 4.2 out of 5. Users mainly appreciated the speed of response, ease of use, and 24 by 7 availability of the system. So that is really important about the AI chatbot. So in the statistical summary, these slides definitely have the analysis about the statistics. The chatbot achieved a mean response time of 2.58 seconds compared to 40 seconds for a human support, with a statistical significant difference of p less than 0.01. So user satisfaction remained high with an average score of 4.2 out of 5. So these results confirms both the performance gains and positive user experience. For the error handling and limitations, the chatbot successfully resolved 84% of queries without a human support. So the remaining 16% involved complex cases, mainly multi-intent queries, context loss, and mixed Arabic English inputs. So in such cases, the system used a clear fallback response and redirected users when needed. Our findings confirms that AI chatbots significantly reduce staff workload and improves service scalability in higher education. So the proposed system shows performance comparable to code-based performance and platforms such as IBM Watson and Dialogflow and Rasa as well. The key advantage is the no-code deployment, which allows faster implement without like technical complexity. In ethical and privacy compliance, the system follows strict privacy and ethics standards. So, with no personal data stored and fully encrypted communication. So, bias risks are monitored, and human escalation is planned to ensure responsible AI use. In the conclusion, and future work. We successfully deployed an AI chatbot using Microsoft CopilotStudio. The result shows faster responses, high user satisfaction, and better operational efficiency with strong potential for adoption across all the universities. Future work enhancement will focus on stronger Arabic language supports, better multi-turn context handling, and smooth live agent escalation for complex cases. That's all from our presentation. Thank you so very much for your time and attention, and I really appreciate your patience. We welcome your queries and future collaboration. Thank you once again.